Hi everyone, this is Karthika, Faculty of Physics, working in SNS College of Technology. So in this session, I'm going to explain about the different types of laser. So we have different types of laser based on the material we are using. Here we have a solid laser, liquid laser, gaseous laser, and then dye or chemical laser, and then semiconductor laser. So in solid laser we have NdOC, that is neodymium, yttrium, aluminium, garnet. In liquid laser rhodamin, gaseous laser, CO2 laser, and helium-neon laser. Dye chemical laser polyphenol, and then semiconductor laser homojunction and heterojunction, that is gallium arsenide and gallium aluminium arsenide. So here we can see about the neodymium yttrium aluminium garnet laser. So here the type is doped insulated laser. Active medium is yttrium aluminium garnet. Active center is neodymium. Pumping methods is optical pumping. Pumping source is xenon flash lamp. Optical resonator is nothing but ending of rods with silver coated, and two mirrors can be act as a partially reflecting, and then the power output is 20 kilowatt, and the nature of output is a pulsed one. Here it is a doped insulator laser. The atoms the neodymium atoms can be moved to the excited state and then come back to the ground state, that can be emitted the laser light. So this is the construction of NdOC laser. So here shows the elliptical cavity. It contains the flash lamp, that might be the xenon or krypton, and the laser rod which will emitted the atoms will be present inside the elliptical cavity, and the end of that rod will be polished with silver, and then we have two mirrors. One is 100% reflecting mirror, another one is partially reflecting mirror. This will act as an optical resonator, and it can be connected by the power supply. So when the power supply is on, due to that flash lamp, the atoms present in the laser rod absorb some energy and moves to the excited state, and from the excited state to ground state it transfers. The light can be emitted. The energy level diagram shows the transition here, and the Nd3 plus atoms can be moved to E2 and E3 level. So from E3 to E4 there is no any radiation by emitting the decays, and E4 to E1 that will emit the laser, that is 1.064 micrometer, and E1 to E0 that is non-radiative decay. So during that time, um, there is no any radiation. So the applications is nothing but transmission of single signals over a large distance, long haul communication system, endoscopic application, remote sensing. Next we can see the carbon dioxide laser. The principle, the transition between the rotational and vibrational energy levels leads to this molecular gas laser. Here the transition made from the vibrational modes. Here we can see the type is nothing but molecular gas laser. Active medium is mixture of carbon dioxide, nitrogen, helium, and water vapor. Active center is carbon dioxide, and pumping method is the electrical discharge method. The optical resonator is gold mirror or silicon mirror coated with AI. The power output is 10 kilowatt. Nature of output is continuous or pulsed. The wavelength emitted is 9.6 micrometer or 10.6 micrometer. So here we have a three vibrational mode. One is the symmetrical stretching mode, bending mode, and asymmetric stretching mode. So in symmetric stretching, we have a carbon atom will be the stationary, and the two oxygen atoms vibrates approaching and departing each other. In bending, carbon atom and oxygen atom vibrates perpendicular to molecular axis. In asymmetrical mode, a carbon and oxygen atom vibrate in opposite directions along with the molecular axis. So we can see the construction. So here we have a quartz tube, so that contains all the gases like carbon dioxide, nitrogen, and helium. And at the end of this quartz tube we have a Brewster window NaCl, so that will polarize the light source, and we have a optical resonator some mirror, and here the carbon dioxide atoms can be moved to the excited state to ground state, and nitrogen helps for the population, and helium helps for the depopulation. And the working given as a equation, that is nitrogen atom collide with the electron and absorb some energy, moves to the excited state and emit the electron, and the excited nitrogen collide with the carbon dioxide, moves to the carbon dioxide in excited state and the nitrogen. And the applications is nothing but it can be used in a bloodless surgery and all. Here we have energy levels that can be taken as E1, E2, E3 and E4. So where the transition from point 1 degree to 10 degree, so we'll have a 10.6 micrometer output, and then uh, 0.1 degree to the 2 degree we have the 9.6 micrometer output. So this is the output range. Thank you.